Proprioception is the sense of one's own body parts. This information comes from muscle spindles and Golgi tendon organs. We will be focusing on non-conscious proprioception, which works as a reflex to let us perform actions without thinking about them. Non-conscious proprioception has two pathways, the anterior spinocerebellar and the dorsal spinocerebellar.
Somatosensory information carried via axons of sensory neurons of the Golgi tendon organs and muscle spindles enter the dorsal horns of the spinal cord. Some of the information immediately switches sides or decussates to the anterior spinocerebellar tract. Second-order neurons then travel up the tract until they reach the junction between the pons and the medulla. The information then decussates back to the ipsilateral, or same side, and enters the cerebellum through the superior cerebellar peduncle. Similar to the anterior pathway, somatosensory information comes from Golgi tendon organs and muscle spindles and enters the dorsal horn of the spinal cord through the dorsal root ganglion, which is a first-order neuron. Information then travels up the ipsilateral spinal cord until it reaches Clark's nucleus. This is where it synapses onto the second-order neuron. The information then continues to travel up and through the inferior cerebellar peduncle into the cerebellum. At this point, some information decussates and goes through the thalamus to the contralateral S1. There are a few differences between the anterior and dorsal tracts. The anterior tract decussates twice and enters the superior cerebellar peduncle, while the dorsal tract only decussates once, synapses when information reaches Clark's nucleus and information enters the inferior cerebellar peduncle. Both tracts involve two neurons, and although one decussates immediately, the majority of the information enters the ipsilateral side of the brain. Both the anterior and dorsal tracts relay somatosensory information from the lower limbs to the brain. The upper limb tracts consist of the rostral spinocerebellar tract and the caudal spinocerebellar tract.
An injury or lesion to the spinocerebellar tracts would result in a loss of information regarding the constant changing of length and tension on muscles, which often leads to a lack of coordination. Injury normally affects the movements of the same side of the body because both tracts send the majority of their information to the ipsilateral side of the brain. The anterior spinocerebellar tract acts as a backup in case of an injury to the dorsal tract. The double cross allows information to bypass the affected site to avoid the loss of somatosensory information. Usually, injury to the ascending spinocerebellar tracts is accompanied by injury to the descending motor tracts. This leads to muscle weakness and sometimes paralysis, which can mask the loss of coordination presented by the injured spinocerebellar tracts. Spinocerebellar ataxia is an example of a disease that affects these tracts. It is also known as spinocerebellar degeneration and is an acquired or hereditary disease that involves the degeneration of the spinocerebellar tracts. This disease leads to a progressive incoordination of walking and uncoordinated hand and eye movements.
Created using Powtoon.